Okay, hello. We are going to learn how to do phenotypes and genotype percentages and ratios. Figure out how to do those. All right. So the easiest way is to start obviously with the Punnett square, and the best way to do it is to look at two heterozygous parents coming together. So we've got two heterozygous parents, big B, little b, and big B, little b. So we want to segregate and independently assort, and they all go on their own little box. Okay, so we end up with a Punnett square that looks something like this. All right. Now, there are some questions that are fair game for asking about these possible offspring. So the big thing you want to know is, you know, what percent chance do I have of my kid having blue eyes or brown eyes? Something like that. So the first thing we'll start off with is phenotypic percentages. Okay. So the first thing you do is you decide, well, what phenotypes could I possibly have? And let's just go with the blue and the brown-eyed example here. So remember, brown is dominant to blue, so brown's going to be the big B. So first thing you want to do is write down your categories. So the question will ask something like, what percent chance do these two parents have of having a baby with brown eyes? So percent brown, that's going to be, you look at how many brown you have over 4 out of 4. So you've got one brown here, another brown here, and another brown there. So you have 3 possible offspring that would end up with brown eyes out of 4 total. So you have 3 out of 4, which is going to equal 75%. All right. Then what if I want to know what percent chance do these two parents have of having a kid with blue eyes? Well, you've only got the one little box that ends up with blue eyes, so that's 1. Oh, this is going to be percent blue. And you have 1 out of 4 total equals 25%. 25% chance that 2 heterozygous parents end up with an offspring that is homozygous recessive. All right. Now, while we're still on percentage, we can also ask you genotypic percentages. Genotypic percentages. All right. So, I said, what percent chance do these parents have of ending up with a kid that is homozygous dominant? Okay, so you go look at your Punnett square. Okay, I've got one kid here that's big B, out of 4 total. So that's 1 out of 4. And that's going to be 25%. Right, then what percent chance do I have of getting a heterozygous kid? So you look, we've got 2 heterozygous here out of 4 total. 2 out of 4 is equal to 50%. All right, then what percent chance do I have of ending up with a kid that's homozygous recessive? That's going to be 1 out of 4 total. So 1 out of 4 equals 25%. All right, now ratios. All right, we have the same parent. Wait, go away. All right, same 2 parents, both heterozygous. So the Punnett square is going to look exactly the same. We're just on new page. Now this, we're going to do ratios. So ratio, that's supposed to be an S. Ratios are a little bit different than percentages. When we had percents, that percentages, let's write this in red so you can see it. Percent means part over the whole. Oops. W-H-O. Right? So that's always going to be something, whatever it is, out of 4. Right? Now when we do ratios, that is one thing to another thing, right? So you're just comparing really what are the numbers here instead of out of the total. So there's some steps to make this a little bit easier to follow. The first step you want to do is decide / write down the possible, not your possible, the possible outcomes. So if it's asking you for a genotypic ratio, write down all the possible genotypes. If it's asking you for a phenotypic ratio, write down all the phenotypes. So let's do let's do phenotypic first. Right? So all the possible outcomes are either brown, remember phenotype is physical appearance, or blue. Okie doke. So the next step is you count how many of each outcome, using outcome the same way that we did out up here. Okay, how many of each outcome are in the Punnett square? Punnett square. All right. So now what we're going to do, okay, we've got one brown here, another brown, and another brown. So that's 3 browns in our Punnett square, so you write that down. And then you have one blue here. 1. All right. The last step is you put a colon between the two numbers. Between the numbers. All right, and then if you can, you reduce at the end to make it look nice and pretty. So all we do is just put a colon right there. And so if you write that the right way, it would look like this. 3 to 1. For every 3 brown phenotypes we have 1 genotype, 1 blue phenotype, 3 to 1. All right, so now if we wanted to do genotypic ratio here, we'd follow the same steps. Write the possible outcomes. Okay, well I've got 3 here, so I can either have big B, which is homozygous dominant. I can have heterozygous, which is going to be big B, little b. Or I also have homozygous recessive, little b, little b. Right? Now I'm going to count how many of each I have. So how many homozygous dominant do I have here? 1. All right? Remember, only percentage is when you say 1 out of 4. Right now, for ratio, you're just saying I have 1, and that's it. Okay? Now, how many heterozygous do I have? 2. I've got 2 of them. And how many homozygous recessive do I have? 1. Little b, little b. Right? And then I put colons between the numbers. And if you flip that, make it look pretty, I have 1 to 2 to 1. All right. Now, the one last thing that's a little bit weird about ratios is when you have something that ends up looking like this, where you end up with something that all looks the same on the inside. So if I cross 2 homozygous dominant parents, I'm obviously going to end up with all homozygous dominant kids. So that's the only only alleles they can give away. So if I wanted to write percent of brown eyes here, be 100. I have 100% brown-eyed kids. If I want to do 100% blue, 0, right? I don't have any blue-eyed kids here. In order to be blue, you have to be little b, little b. So that'd be 0. right? Now if I want to do a phenotypic ratio, since we're on phenotypes, okay, remember we list all the phenotypes we have. So all we have here is brown, and I have 4 of them. And I don't have any blue, so I just put a line, like NA. Alright? Now, this is a weird thing about ratios that end up being just all the same. So you got to think about 4, and you have to think about reducing 4 by itself, which is kind of weird, but you just need to know that if you have something that ends up that it's all the same like this, the ratio is going to reduce to just 1. So if this question came up and it asked, what's the phenotypic ratio? Your answer would just be, you'd write it in just 1, and that's it. And it's the same with the genotypic ratio. Okay, you have all homozygous dominant. That's the only option you have. And you have 4 of them. So that's going to reduce to 1. That's kind of weird, but you just need to remember it. Okay, and that's it for how to figure out phenotypic, genotypic, percentages, and ratios.